Hello everyone, welcome to LFI Educates. Today we will continue with the lesson Electric Conductors and Insulators. A circuit is when we connect an electric energy source with an electric object using a wire. A circuit can be of different types and can have different components in a circuit. The circuit shown here is a series circuit, which means there is only one path for the flow of electricity. We have the bulb, the battery, and a switch connected with wires. Here, there is only one way or path that electricity can flow through. So, this is an example of a series circuit. To make it easier and simpler for everyone to understand, we have symbols for different components, so it is easier to understand the circuit diagram. The symbols are universally used, so everyone will understand. Here are the symbols for few circuit components. 1.5 volt cell, two 1.5 volt cell joined together, 3 volt battery, connecting wire, bulb, open switch means switch when it is off, closed switch means switch when it is on, bell means electric bell like a doorbell, buzzer, a device which makes a buzzing sound like in some toys, and motor, it is used to spin the turbines and used in fans and toys. When we change the components in the circuit, we will notice a difference. For example, in this circuit, which has only one 1.5 volt cell, if we add one more 1.5 volt cell, then the light will glow brighter as it has more energy. If we add one more bulb in this circuit, then the light will be dim as it has to share the energy. So we can say that we will notice that on adding or removing bulbs from the circuit, it causes them to glow more or less brightly. Adding or removing cells used in a circuit causes bulb to glow more or less brightly. Different components of a circuit need different strengths of electricity. The strength of electricity is measured in a unit called volt, that is V. This bell needs 6 volts to work. This bulb needs 1.5 volt to work. This buzzer needs 3 volts to work, while this motor needs 24 volts to work. We add the cell according to the amount of volts the component need. We can add 2 or more cells for this. If we have more cells, then the component will work better. But if the volt is less, then it will not work. The length and the thickness of the wire will also affect the strength of current. If the length of the wire is long, then less current will flow than the short wire of same thickness. If the wire is thicker, then more current will flow than the thin wire of the same length. Both thick wires and thin wires are useful for us. Thick wires are used to get electricity to our homes, and the thin wires are used in electric gadgets and bulbs. Batteries are very useful to us. We use batteries in many things in our day-to-day life. The invention of batteries has undergone experiments conducted by many scientists and observations. In June 1936, workers found an ancient tomb while they were constructing a new railway near the city of Baghdad, in present-day Iraq. Archaeologists identified things in the tomb to be 2,000 years old. At this time, people called the Parthians lived in this region. One of the old objects or relic they found in the tomb was a clay jar. The jar had an iron rod coming out of the center, surrounded by a tube made of copper. Scientists made copies of this relic. When they filled the tube with acid such as vinegar, it produced about 1.5 to 2 volts of electricity between the copper and the iron. Archaeologists think that people who lived 2000 years ago used this battery to cover metal objects with gold. Luigi Galvani was an Italian doctor. About 1780, he discovered current electricity. He hung a frog's leg on copper hooks over an iron railing and noted that the muscles twitched. Galvani was correct when he said that the twitching was caused by the electric current, but he thought that current came from the frog's leg's nerves and called it animal electricity. Alessandro Volta was an Italian university professor. He repeated Galvani's experiment many times with different materials. From this experiments, he came to the conclusion that it was the two different metals, copper and iron, and not the frog's leg that produced electricity. The frog's leg contained a fluid which conducted the electricity. It twitched because the electricity was flowing through it. After many experiments, he developed a type of battery that he called a voltaic pile. This consisted of a pile of zinc and copper disc. Between each disc, there was a piece of cardboard that he had soaked in salt water. A wire connecting the bottom zinc disc to the top copper disc would produce a continuous flow of sparks. Volta built different piles using 30, 40, and 60 discs. He measured the reaction with different numbers of discs and discovered that electric shocks increased in intensity with the number of discs he used in a pile. Later, scientists improved Volta's battery by doing more experiments. This is all we have for today. Thank you and have a good day.